All right, let's take a look at two final problems involving U-substitution. Now this first one is nothing special about it. It's just going to be a definite integral, but it will require double substitution. The first substitution will not get rid of all the x's. So to start with, let's take this square root that's in the bottom. That'll be like having this thing to the 1/2 power. Let's move it to the top and make it be to the negative 1/2 power. So my first step will be to integrate from 0 to 4. And again, the square root of something is like something to the 1/2 power, but it's a positive 1/2 in the bottom. When I move it to the top, it'll become a negative 1/2. So 2x plus 1 to the negative 1/2 power. Then I'll take this x, move it off to the side, and that gives me an x dx. And this is what I'm going to try to get rid of. So I'll put a little box around this. Now again, if you have not watched the previous U-substitution videos, I'd watch those so that you'll understand how we've gotten to this point. Now when I do this, my choice of U is going to be what's inside the parentheses here, so that'll be a choice of U. So just like all the other ones, we'll go ahead and let U be equal to 2x plus 1. Now find the derivative of that. So derivative of U with respect to x would be equal to 2. Therefore, the differential of U would be equal to 2 times the differential of x. Now over here I need a dx, and I've got a dx, but I don't need the 2, so I'll move this 2 to the bottom on this side, which will get me to 1/2 du will be equal to dx. Now at this point, I needed a dx and I've got a dx, so this agrees with what's up here, and I can substitute for this part right here. So that will be my substitution. And just like on all the other ones, we'll go ahead and put a little box around this thing. So there's the first substitution. So there is the U substitution. Now when you plug that in, here's what you come up with. This is going to be the integral of U to the negative 1/2. Now, the trouble is I didn't get rid of everything. I've still got this x right here, so I think I'll put it in red just so it kind of stands out. So that x I have not taken care of yet, but the dx is equal to 1/2 du, so I can put a 1/2 du right here. So there's 1/2 du. Now, this is going to require a second substitution because the first substitution did not get rid of all the x's. So what I've got to do now is to get rid of this x right here. And to do that, I'll move back up here and starting with U is equal to 2x minus 1. So I've got U is equal to 2x plus 1 plus 1. First of all, take the 1 from this side, move it over to this side. That gets you to U minus 1 is equal to 2x. And again, you need an x, not a 2x, so divide both sides by 2, which will get you to this. 1/2 of U minus 1 will be equal to x. Now, you needed an x, and you've got an x right here. So this time, you can trade this one out for this, 1/2 of U minus 1. And what that is my second substitution. So we'll again stick a little box around this. So here is the second substitution here. And this will get rid of that second x. So there is the second substitution. So what that's going to do is to replace this will become the integral, and again from of U to the negative 1/2, and in place of x, put what x is equal to. So I think I'll do it in blue where it kind of stands out. So this will become 1/2 of U minus 1. Then I've still got the 1/2 du right here. So when I make my substitution, this x turns into 1/2 of U minus 1. Now let's also look at the limits on this. We're going to do exactly what we've done before. We'll have to change the limits on this one. So this goes from x equals 0 to x equals 4. So I'm going to change it to u limits because what I want to have down here is from u equals something to u equals something. So I've got to set my new limits. So I'll do it exactly like we've done in the previous videos. I'll first of all work with the top limit. So when x is equal to 4, then u is equal to 2, and you're just using this over here, so plug a 4 into this. 2 times 4 plus 1, which would give you 9. Now get the lower limit. So when x is equal to 0, then u is equal to 2, and this time plug in a 0 plus 1, which will give you 1. So there will be your new limits. So that's where I found the new limits. So when x is equal to 4, u is equal to 9. That'll go right there, top limit. When x is equal to 0, u is equal to 1. So I'm going to integrate this thing from 1 to 9. Okay, now I actually finished through with the integration. Now it's just a matter of solving this. So what this is going to be, first of all, I'll take 1/2 times 1/2 is 1/4. That's a constant, so I'll bring it out in front. So this will be 1/4 of the integral from 1 to 9 of u to the negative 1/2 times u minus 1 du. Okay, so that's going to be 1/2 of, now the next step is to go ahead and distribute this u to the negative 1/2. So I'll multiply it times that and times that. And that will get me to, now this is like having 2/2 plus a negative 1/2. This will get me u to the 1/2 minus u to the negative 1/2 du. Oops, that's a mistake. This one should be 1/4. So let's back up and change this to a 1/4. So that little thing right there, let's make that be 1/4. So 1/4 of this. Okay, now find the antiderivative of that. So that's going to be 1/4 of, and again, you'll add 2/2 to each one of these. This will become u to the 3/2 divided by 3/2 minus, and when you add 2/2 to this, this will be u to the 1/2 divided by 1/2. And it's going to be evaluated between 9 and 1. Well, again, I'll take both these fractions and invert and multiply. So this will become 1/4 of 2/3 u to the 3/2 minus, invert and multiply this one, 2 times u to the 1/2, evaluated from 9 to 1. Okay, now you'll just go ahead and plug in, first of all, plug in the top number and then plug in the bottom number. So this would be 1/4 of, and we'll plug the top number in here. Move this up just a little bit. So plug in the 9. So this will be 2/3 of 9 to the 3/2 minus 2 times 9 to the 1/2. So there is the top number, then minus the bottom number. So plug in the 1. So 2/3 of 1 to the 3/2 minus 2 times 1 to the 1/2. So it looks like that. Okay, now we'll take that and make it be 1/4 of, and again, scoot it up just a little bit. This is going to become, now think of this as being the square root of 9 is 3, cubed would be 27, so this will turn into 2/3 of 27 minus 2 times, and 9 to the 1/2 is like the square root of 9, which would be 3. Then minus, now 1 to any power is 1, so this will become 2/3 minus, again, 1, square root of 1 is 1, minus 2. So you've got that. Now we'll go ahead and simplify this a little bit. This is going to become 1/4 of, now 3 goes into 27 9 times 2 would be 18, minus 2 times 3 would be 6, so there's the first one, and then minus, and think of this as being 2/3 minus, and 2 is 6/3, so this would be like having 2/3 minus 6/3. Okay, so this will be 1/4 of, now 18 minus 6 would be 12, then you've got minus, and 2/3 minus 6/3 would be minus 4/3. Well, what this would be 1/4 of, now since this is over 3, put this one over 3, so that would be 36/3. And then 2 negatives make a positive, plus 4/3. Which gets you to 1/4 of, add those together and you'll get 40/3. And then finally, the 4 goes into the 40 and leaves you with 10/3 for a final answer. So this one's a little bit complicated just because there's a lot of fractions in it, but if you can watch out for all the fractions and follow the process, then it's very much like the ones that we've done before. So again, just to kind of review from the start, first substitution does not get rid of all the x's. You still have this x left over right here. So a second substitution removes all the x's, and this x turns into this. Now you've got the whole problem in terms of u. But you also need to change the limits. So we change the limits. Then once you've got it all in terms of a u problem, then it's just a matter of running through the algebra to solve the whole thing. So there's a sample of a U-substitution definite integral, but that requires a second substitution. Okay, now in the second problem, occasionally you run across a problem where half the problem is U-substitution and half of it is not. Now look at this problem. You've got the cosine. Now it's not times, it's addition. So the cosine of x plus the sine of 2x. Now what you'll find is that the cosine of x is not a composite function. It's just a simple x, so you don't have to use U-substitution. But on this second one, the sine of 2x, that is a composite function. You've got 2x inside the sine. So this one will require U-substitution. So the trick on these problems is to do the following. Split it up into 2 parts and solve each part separately. So what I'll do, I'll change this into, this side will be the integral from 0 to pi of the cosine of x dx, and then I'll add that to that, put a plus here, the integral from 0 to pi of the sine of 2x dx. So split it up from a single integral into 2 integrals and solve each part separately. Now first of all, let's solve this part on the left-hand side. This is not a composite function, so you don't have to use U-substitution. So in this case, let's go ahead and solve this one real quickly. The antiderivative of the cosine is the sine, so this will change into the sine of x evaluated from 0 to pi. And then we'll go ahead and get an answer for this. And we might as well just go ahead and finish this one up. So this would become plug in the pi, so the sine of pi, then minus the sine of 0. Well, the sine of pi is 0, and the sine of 0 is 0. So you get 0 minus 0, which is 0. Now what that is half the answer to this thing. That takes care of this. Now what I'll do, just to make it kind of stand out here, I'll put a line right down the middle of the page here. So now we'll work the second part of the problem out. So we'll treat this as a completely independent problem, and we'll go from here on down here. So now looking at this problem, but what this one is, this is a composite function, so I'm going to have to use U-substitution on this part. So what I'll do, I'll let U be equal to what's inside the argument of the trig function. So using my U-substitution, that gives me U is equal to 2x. So derivative of U with respect to x is equal to 2. So that gives me the differential of U would be equal to 2 times the differential of x. Now again, what I'm going to try to get rid of here is this dx right here. So I don't need the 2 dx, so I'll take the 2 from this side, move it over to this side, and that gets me to 1/2 du is equal to dx. Now, there's the dx. I needed a dx and I've got it, and I'll substitute it out for what I've got right here. So there is my U-substitution. So there is the U-substitution. But now I also need to change the integrals, the limits, because remember this goes from x equals 0 to x equals pi. Well, what I've done, I've changed this thing into the antiderivative of the sine of u, and in place of dx I've got 1/2 du. But I've also got to change the limits into u limits. So what this is going to be, this would be from u equals something to u equals something. So let's change the limits. So when x is equal to pi, we'll do the top limit first. When x is equal to pi, then u would be equal to, and plug pi into this right here, u would be equal to twice pi. Then let's get the lower limit. When x is equal to 0, then u would be equal to twice 0, which would be 0. So here are my limits. So I did the U-substitution, and I also changed the limits. So this down here, I'm going to go from 0 to 2 pi. So now I'll solve this as a separate problem. So what this is going to be, first of all, bring the 1/2 out in front. So 1/2 the integral from 0 to 2 pi of the sine of u du. And what that will be equal to would be 1/2 the antiderivative of the sine is the negative of the cosine of u, evaluated from 0 to 2 pi. Okay, go ahead and plug in the top number. So this will be the negative of the cosine of 2 pi minus the negative of the cosine of 0. And what that's going to get you to would be 1/2 of Now, first of all, you've got the negative. The cosine of 2 pi would be equal to 1, and then minus the negative of the cosine of 0 would also be equal to 1. So that gives you 1/2 of, now this becomes a -1 plus 1, which would be 1/2 of 0, which is 0. Now, the final answer is going to be this. It's going to be the integral of this one added to the integral of this one. Well, the integral of this first answer was 0, so we'll move it down here, and you've got a 0. Then the integral of this second one, in this case, also turned out to be 0, so we'll move it down here. And all you're going to do is just add these two together, so 0 plus 0, both of them turned out to be 0, and 0 will be the final answer to the entire problem. So again, if you got a problem like this, split it up into 2 parts. So split it up into the antiderivative of this one plus the antiderivative of this one. Then solve each one of them separately. Get an individual answer for the first one, get an individual answer for the second one, then add the 2 of them together and you've got the final one. But this is a sample of a problem where half the problem required U-substitution and the other half of the problem did not. So you'll run across that occasionally. So just a couple more examples for you.